Okay, so we're going to take our knowledge about midpoints and segment bisectors. We're going to take it off the number line in the coordinate plane and just work with segments in space. Um, so we're going to just kind of carry the concepts forward. We have, the same vocabulary. Nothing's changed here. We have midpoint, which is the point that divides the segment into two congruent segments. Keep in mind, as we're working with these segments, for example, if we call it, and it doesn't matter, LM, if we say B is the midpoint, LB is congruent to BM, measurement of LB is equal to the measurement of BM. And again, the way we show it in the picture are the little hash marks. Single tick marks or hash marks tell us those are congruent. If there were doubles, that would be okay. It would just mean a second pair. So, whoops. Got to work on that screen. All right. As I was saying, if we had a second pair of hash marks on there, that'd be fine too. It just means that they're congruent. And a segment bisector is anything that bisects the segment. So right now, point B is the bisector. The segment LM got bisected. And that's really important language. Let's look at a few examples of these pictures. For example, in our first one, point C is the midpoint of AB, segment AB. We know that. We can see that in the picture. It has the little hash marks, and that means that AC is congruent to BC, and the measurement of AC is congruent to BC. In our second one, line K is a bisector of the segment DE. So DE got cut into two equal parts. Remember, bisect means two equal, congruent, smaller parts. If we started with a segment, we have smaller segments. If we started with an angle, we have smaller angles. So here, if we're told line K is a bisector, then that means it goes through the middle or the midpoint. So that means F is the midpoint of DE. And of course, we have two smaller congruent segments that are equal in measurement. So the concepts that we're seeing in these pictures are really important. Knowing what got bisected. So let's take a look at this one. RS bisects LM. So think about that really carefully. RS cut LM in half. That's how we have to translate it. So again, when I see this, that means RS cut LM in half. And those are segments. So I know LM got cut exactly in half, making the two little pieces congruent, making their measurements equal. P is the midpoint. We know all of this now. We know that LP and PM are congruent. But we also know from segment addition that LP plus PM equals LM. So we have two possible equations. We can set the two parts equal, or we can add them together to get the whole segment. Notice what we don't know about segment SR. Was it cut into two pieces? Yes. But was it bisected? Nothing tells us that. Nothing says that SR was bisected. The only thing we know about SR is that it is made up of two smaller pieces, and we can add them using segment addition to get the bigger segment. So it is really important when you look at a picture, when you read the directions and the given information carefully, that you know which piece was bisected, which piece do we not know anything about, so that you can choose the correct approach. Remember, geometry is just rules. You have to know how and when to use each rule. Let's look at a few things, and we'll draw a picture. We're not going to do them all, but we'll draw a picture. So let's look at number one. Line RS bisects segment PQ. Line RS bisects. I need PQ first. I can't cut the sandwich unless I make the sandwich first. So I need PQ first. Now, we have a line that bisects it, so it's going to go right through the middle. It's going to go through that point right there, and it's a line. That line is called RS, but it bisects it at R, so that means right there is R. S is just somewhere on there. Doesn't matter, but R has to be in the correct spot. Now, if we notice what we have here, PQ, the whole thing is 14. We were asked for RQ. Well, if we bisected it, that means we cut it in half. And 14 divided by 2 is 7. So RQ is 7 units and PR is 7 units. Getting the picture drawn correctly is really important there. Let's take a look at another one. Let's take a look at number 2. So number 2, let's bring that over here. JK bisects MN. So again, I need MN. So M, and those could be reversed. That doesn't matter. I need a line that bisects it. So I'm going to go right through the middle. So there's a line. It's called JK. And again, we bisected at J. So we bisected it at that point called J. And then K is somewhere on there. And again, it doesn't matter where. It's just somewhere. We're told JM is 6 3/4. 6 3/4. And we're asked for MN. So we're being asked, what is the whole thing? Well, MJ plus JN would equal MN. And remember, what does bisect mean? It means the two little pieces are congruent. So that means they're both 6 3/4. So I have 6 3/4 plus another 6 3/4, and that equals MN. Well, 6 3/4 plus 6 3/4 is 13 1/2. And this should be in fraction form because we were given fractions. So 13 1/2 is a better answer than 13.5. Okay. So two things happening when we work with midpoints. Either the two little pieces are equal, or we add them up to get the big one because segment addition didn't go anywhere. So in this example, we're adding MJ and NJN. And as long as we know the measurement of one, we know the measurement of both. Okay. Let's see what other examples we have here. So M is the midpoint of the segment. Find the indicated length. Well, let's think. If M is the middle, and they even showed us in these pictures, they're showing us that these are congruent. They put the little hash marks on there. So that just means x plus 9 is equal to 4x. And if we do a little bit of algebra, we get x equals 3. But read the directions. It said find ln. So we're not done. We have to plug it in. Make sure that you reread directions to see what you actually have to do. That gives us 12 and 12. So ln is the whole thing, 24. We used our knowledge of bisect and midpoint to set them equal. That let us find x. Then we plugged it back in and we used our knowledge of segment addition to add the two little segments together to get 24. Again, we'll do one more. I'm just going to give myself a little room here. Let's do number 6. The segments are congruent, so we can set them equal. So we'll do a little bit of work. We've got 4x, 24, x equals 6. We were asked to find AM. Plug it in. AM is x plus 20. So AM equals 6 plus 20 for 26. So this is 26. Well, MC is also 26. We can plug it in, but we know that they're congruent. If we were asked to, we can say AC is AM plus MC, so that's 26 plus 26, and AC equals 52. Again, if we were asked to. The point is, use the rules to find x. So we always want to draw a picture and label it. They gave us that. Set up our equation according to the rule that we're going to use, and reassess. Once you find x, you might not be done. Read the question carefully. If you stop at x, you did 99% of the work to get it wrong. Make sure that you reread the question and you plug it back in if that's what you're being asked to do. Let's see what else we have. Okay, so here we have an example where we're not even given the picture. We have to draw it ourselves. So that's okay. That's really not going to make it any different. Let's do, I don't know, let's do number 2. F is the midpoint of GH. So I have H, and F is in the middle. So those two segments are congruent. So stop and think about what we know. We know GF is equal to FH, and we know that if we added them, we would get GH. Now, I don't know which of those equations I'm going to use yet, but I'm just understanding the picture. The two little parts are equal, and if I add them together, I get the whole thing. Now let's see what we're going to do. GF is x plus 1. X plus 1. GH is the whole thing. Make sure you label things correctly. That's 5x minus 4. Well, I have to figure out how to connect them. Are they equal to each other? Definitely not. GF is one piece of it, and GH is the whole thing. So I'm always going to ask myself, are they equal? And if not, how can I get from the small one to the big one? So they are not equal. They are absolutely not equal, which means this is the formula we're going to use. The question is, what are we going to put in? Well, GF they gave us. It's x plus 1. And GH they gave us. It's 5x minus 4. But what are we going to put there for FH? Well, look at our picture. Those segments are congruent. So if GF is x plus 1, FH is also x plus 1. That's what we're going to put there. So we're using our knowledge of midpoint and bisect to say, if you gave me this one, now I know that one. Algebraically, what we're going to do here is add the two little ones to get the big one. So segment addition. 2x plus 2 equals 5x minus 4, 3x, 6, and x is 2. And knowing x is 2 is really important. It's just that we're still not done. The question asks us to find GH. Reread the question. Find GH. Okay, we are always going to find x. But then in this one, we need GH. So GH, they told us, GH was 5x minus 4. We're going to plug it in. That's 10 minus 4. So GH equals 6. And we can easily, very easily double check it by plugging it in everywhere. If we take that value and plug it in everywhere, see, look at what we get. We get 3, we get 3, and we get 6. 3 plus 3 really does equal 6. So our check is plug it in everywhere and make sure the numbers really work. But that's midpoints and segment bisectors, right? Just be careful with the way you label things.